In the last video, we looked at how working memory is like your brain's post-it note. In this video, I'm going to tell you where working memory is in your brain. Right here, the prefrontal cortex of your brain. It's when you do a test, a working memory test, brain imaging studies show that your prefrontal cortex right here is what's working the hardest. That's why it's so important for football players, for skateboarders, to wear a helmet. You need your working memory. If you damage your prefrontal cortex, you damage your working memory. Well, now that we know where working memory is, let me give you a quick test of working memory to see how you do. Listen carefully. Oranges live in water. True or false? It's not a trick question. I hope you said false. Here's another sentence. Lions have 4 legs. True or false? I hope you said true. Now, can you tell me the last word from each sentence in the correct order? If you said water and legs, congratulate yourself. You have the working memory of an average 5-year-old. What we're going to do is look at how working memory develops across a lifespan, and it's really important to understand what a working memory is like at different ages. As we see, the average 5-year-old can remember 2 bits of information, and I've used apples to illustrate this point. That might be 2 words, 2 numbers, or 2 instructions. When I was speaking in Seattle some time ago, a kindergarten teacher told me that it made so much sense, and she changed the way she ran her classroom. Instead of giving her 5-year-olds 4 things to do, which she now realized exceeded what the average 5-year-old could remember, she cut the instructions down to just 2 bits of information, and she found her class transformed. They were much less rowdy, much less unruly, and were able to keep up with her instructions. As we get older, it gets better, so the average 10-year-old can remember 4 pieces of information. Again, 4 words, 4 instructions, 4 apples. In our teens, we're at our peak, and we can remember 6 pieces of information. We remain at this excellent level of working memory in our 20s and even in our 30s. So good news for some of you out there. In our 60s, we start looking like an average 10-year-old again. So now you have an excuse if you forget to pick up the milk on your way home. Some people think that working memory is the same thing as short-term memory. It's not. In short-term memory, all you're doing is remembering information. But with working memory, you actually have to work with that information. You have to do something. Let me give you an example. If a teacher says to her students, I'm going to give you 3 words, remember them: dog, cat, mat. If the child just has to say those words back to the teacher, they're using their short-term memory, just to remember that information. But now, if the teacher says, can you tell me which of those 2 words rhyme? The child then has to remember the information plus work with it to come up with cat and mat. They're using their working memory. Let me give you one more example. If a teacher says 2 numbers, 5, 8, a student would be using their short-term memory just to remember those numbers. But if a teacher then asked them to add those numbers together, they'd be using their working memory. They have to keep those 2 numbers in mind, add them, and then tell the answer back to the teacher. They're working with that information. And that's how working memory is very different from short-term memory. You actually have to work or manage that information. In the next video, we're going to look a bit more closely at how working memory impacts classroom activities.